Welcome to Integrated Math 3. On this episode, Stevenson will demonstrate
I want to show you how you can work with logs individually and how you can solve logarithmic equations. These are simple ones, but it depends on what is unknown. With a logarithmic equation, there's three possibilities that could happen that dictate how you approach the problem. So you can have an argument that's unknown, the exponent could be unknown, or the base could be unknown. So let's look at the first one. The argument is unknown. So you can see here, the base of the log is 4, the argument is unknown, it's just y, and this log equals 3. So what we're going to do here is we're going to convert this into exponential form. Now, from this point here, we can see it says y equals 4 to the power of 3. So we could just apply the power here on 4, and then actually we figure out our answer. And there we have it. So the argument for this log is going to be 64. Now, in this example, the exponent's unknown. So remember, logs equal exponents. So this one's what's not. So again, we're going to convert to exponential form. Now, this one's a little bit tricky. It's not as straightforward as the previous one. In the previous one, as soon as we converted it, we immediately got our answer. It's very convenient. Here, what we want to do is we want to convert these so they have the same base. Okay, so let's do some work with 64 here. Okay, so what I'm trying to do is I'm trying to break down 64 into powers or groups of 4. So what I could see is I have 1, 2, and those two together make an additional 4. So I know that 64 is really 4 times 4 times 4. Now that's important because now I can rewrite 64 as 4 to the power of 3. And notice, when the bases are the same, then the exponents must be the same. Now we know what the unknown power is. So what if the base is unknown? Well, again, we're going to convert to exponential form. Right? Now, so we have some unknown base to a power of 3. So again, we would take 64 and we would break it up into something that's a power of 3. So again, we would get 4 to the power of 3. So I'm going to rewrite 64 to the 4, or rewrite 64 as 4 to the power of 3. Okay, now check this out. In this situation, the exponents are the same. If the exponents are the same, then the base must automatically be the same. So let's make a note of that in these two cases here. So if you have the same base, then that implies the exponents must be the same. And when you write it, notice the bases go away and you just write x equals 3. In this one here, we had the same exponent. So if you have the same exact exponent, then that implies you have the same base. Now keep in mind, this is with a single quantity. Okay, so in other words, there's no no addition or subtraction or other values on this. It's a single quantity raised to that same power. Up here, it's a single quantity base that's raised to a power.